Okay, well, welcome everybody. Welcome to UCL if you're not from UCL. And if you are from UCL, welcome to the Gustav Tuck Lecture Theatre. You know you're in a serious place when it's got wooden seats, yeah? Gives this august ceremony. But anyhow, welcome. And thank you very much for coming along this evening. For those of you that don't know me, my name's Simon Marnie, and I'm currently Director of the UCL Centre for Digital Humanities. So welcome again. This is the 4th annual Susan Hockey Lecture in Digital Humanities. The series was originally set up to celebrate the 5th birthday of UCL Centre for Digital Humanities. So this is the 4th one. Do the math. We're now 8 years old. Yay, big cheer. So the lecture series is named after Susan Hockey, who's an emeritus professor at Library and Information Studies here at UCL. And Susan was a leading figure in the establishment of humanities computing as an academic discipline in the 1980s and 90s. Indeed, she was head of School of Library, Archives and Information Studies here at UCL. She was chair of the Association of Literary and Linguistic Computing from 1984 to 1997 and founded the journal Literary and Linguistic Computing, which is now rebranded as a Journal of Digital Scholarship and the Humanities. So Susan's a big figure in our academic field. And the aim of this public lecture series is to celebrate and promote work in digital humanities, the application of computational techniques within arts, humanities, culture, and heritage sectors. Now, I can't take the credit for organizing this. This event was put together by a team of people. Thank you very much. David Bevan, where are you? You're here somewhere. There he is, for Dave. Lucy Stagg, who's on holiday, and Sarah Davenport, who was directing people to the doors. And the design elements by Rudolf Amann, up the back here, our designer at large. So the format for this evening is the lecture. And then after that, we'll have questions, a short Q&A, and then we have a reception downstairs in the cloisters. The session is being recorded, so bear that in mind if you, when it comes to the questions at the end, that we are being recorded. So if there's something that you'd like to say, but you don't want it to go out there on the airwaves, then perhaps save it until after the video has gone off and we're at the reception downstairs. But it's my very great pleasure to introduce Professor Carlo Meghini, prime researcher at the Italian National Research Council in the area of conceptual modelling, digital libraries, and digital preservation. Carlo graduated in computer science at the University of Pisa in 1979 with a research thesis on distributed databases. He's participated in several EC-funded research projects in the area of information systems, digital libraries, and digital presentation. He's been involved in many various European projects since 1988, including DELOS Network of Excellence, BRICS, fantastic acronyms, some of these, aren't they? Yeah. Other ones, Assets and CASPAR, even better. Since 2007, he's been involved in the European Digital Library, Europeana, the one that we all know and love, taking care of scientific aspects of the project. He's published in excess of 90 scientific papers in international journals, books, and conferences. But he's here for the lecture today. What can be said clearly. The role of ontologies in the digital humanities. Carlo, thank you very much.
Thank you, Simon, for the presentation, and thank you, UCL Center for Digital Humanities, for inviting me to give this seminar. I'm very pleased and honored to do it. And since when I received the invitation, I have been wondering what kind of stuff I was going to present, and I thought that maybe this was the occasion for me to do some reflections on what is my activity. And since my activity is basically centered around ontologies, and information systems based on ontologies, I thought of using Wittgenstein's famous quote in the title of the lecture. So this is going to be the main theme, not the only one. Actually, the reflection of my activity is also another main theme that is going on, and this poses the question whether what I do can be said clearly. The assumption is yes, hopefully, and understandably as well. And so I thought of structuring this lecture around two main parts. I will be describing what are the principles that inform what I do or what I try to do as a researcher. And those principles actually span two different levels. One is the knowledge level and the other is the symbol level. Both terms will be clarified as we go along. And the second part will be more devoted to illustrate the projects that I've been working on. So the prototypical artifacts that come out of my little group of people as we attack different areas of the digital humanities. And then I will have some conclusions that summarize the basic, both the principles and the project. So, for the principles, well, I thought that the humanist scholars like to look at the past, and so I thought this was the occasion of doing a travel and moving from now and this place back to August 1980 and to Stanford University, the place where Professor Allen Newell, who was the president of the American Association for Artificial Intelligence, was delivering the first presidential address of this association, a rather important occasion. And the first address had the purpose of guiding the AI community in its path to the design and implementation of the synthetic mind, which is the overall goal of artificial intelligence. So at that time, artificial intelligence was in one of its blossoming. It seems is into another one these days. And there was a lot of activity going on, a lot of projects, a lot of top scientists involved. But in fact, progress was a little bit slow due to the fact that apart from agreeing on the general goal of the artificial intelligence, which is as the synthetic mind, there was disagreement on everything else. So there was the feeling that intelligent behavior is very much related to knowledge and rationality. But apart from this, what is the nature of knowledge, how it relates to representation, and what does the system have when it has knowledge? So these were the basic questions that were asked in a big poll that was run, and on which answers diverged seriously. So Allen Newell thought of addressing the community by tackling these questions, which are at the heart of the artificial intelligence field. So, and he decided to do by discussing the architecture of a computer system. So if we want a computer system to exhibit intelligence, there has to be some place within the system where knowledge and rationality sit when they play a role. So in order to discover where this place is, it starts from the basic elements of computer system, digital circuits, that are put under the control of control units, and so you have this kind of things which look nowadays very different the way they looked in 1980. And then on top of these boards, you build machines, hardware, And hardware can be very different. It can be as small as a laptop, or it can be as large as one of these corridors in data centers that we have nowadays. And on top of machines, you build a software layer. And the first layer is the operating system that is supposed to manage the lower level hardware, talk to the various components, and make them available to the higher level applications that run on top of the computers. So we have applications at the highest level of the hierarchy. Well, where are knowledge and where is knowledge and where is rationality in this architecture? Well, Alan Newell said that there existed a distinct computer system level which lies immediately above the system level, which is characterized by knowledge as the medium and the principle of rationality as the law of behavior. So these 5 levels that have been illustrated so far have been somehow zipped into these 2. The first 3 concern the hardware, and the last 2 concern the software. This is called the symbol level for reasons that the fact that, in fact, here we have symbols and expressions that are pushed around by the software. And then on top of these 2 levels, 2 macro levels, let's say, there is the knowledge level. The knowledge level at which we analyze the agent, the underlying machinery in terms of knowledge as the medium and the principle of rationality as law of behavior. So Allen goes on a long way in illustrating this level. He was very technical in a sense, was not just a philosophical abstraction. It really meant that this level exists. So the system at the knowledge level is the agent. I'm reading from his words. All the quotations in these slides are from a very famous paper. And an agent is composed of a set of actions, a set of goals, and a body. So we are talking basically about robots. So the systems that we build for digital humanities do not have a body, or do have a very simplified body, but in the very general sense. And the agent processes its knowledge to determine the actions to take, like computing a certain value, computing a certain proposition, displaying a certain thing. And the behavior law is the principle of rationality. Actions are selected to attain the agent's goal. So to treat a system at the knowledge level is to treat it as having some knowledge and some goals, and believing that the system will do whatever is within its power to attain better now? Okay. To attain its goals insofar its knowledge indicates. Why is it the knowledge level useful? Well, for a reason that is central, I believe, also to the digital humanities. It permits of predicting and understanding behavior of the system without having an operational model of the processing that is actually being done by the agent. So it is, in a sense, a level of abstraction that takes away all the details of computation, all the technical details of the symbol and the hardware level, and just look at at knowledge and behavior. Okay, so this is the basic view that I would like to propose, and that, as a matter of fact, that we follow in our research in the digital humanities. So, and in the paper of Allen, Professor Allen, you find a very long, very detailed, and I would say very illuminating explanation of what the knowledge level is, something I don't have time to go into now, and it's not even relevant. So what would be the objections to this view? Well, there are several kinds of objections. First of all, how is it that knowledge is into a machine? Knowledge is very tightly linked to our brain, to our nature of human beings or biological artifacts. So how can we talk about knowledge being in a machine? Okay, so this is true, but in fact is not dramatically relevant objection, as the rest of my talk will hopefully manage to show. Another possible reaction is that this message, this view of the knowledge level doesn't bring really anything new. I've always been thinking that way. Well, in this case, if you think that computers are indeed knowledge processor, what I am giving you is that you are doing something right. You have to take it very seriously, because viewing computers as knowledge processor, in my opinion, gives a big kick to what can be done, for instance, in the digital humanities. A more serious objection, I would say, is the distinction between knowledge and belief. So in artificial intelligence, just to say it plainly, the distinction doesn't exist. Okay? Whatever the system, whatever propositions an artificial system has, okay, they are beliefs of the agent, but they are treated like knowledge. Okay? So unless the artificial intelligence system is very related to one specific domain, such as politics, for instance, in which case the distinction is important, typically this is not relevant in AI. But the distinction between knowledge and belief is fundamental in the digital humanities, I believe, because the representations, whether it's evidence that is collected for research or are results of the research, those representations significantly differ from those of the natural and the social science. So here is a quote from Digital Humanities textbooks that I read recently, and that all humanistic communication is only a representation of worlds irretrievably past and lost to full understanding. So if I have a system that holds a proposition about an irretrievably lost past to our full understanding, can I consider it knowledge the same way I consider knowledge some theorem of some science? No, of course the answer is no. So this distinction between knowledge and belief is very relevant, and as I will go on, it plays an important role in the way we deal with knowledge and information in the systems that we do. Okay, so the view is valid. It's potentially very rich, but we have to keep in mind that for the digital humanities, we cannot treat representation as being knowledge in the same sense that the hard science, the natural science, and the social science do, but rather from a more epistemological point of view, we have to consider them as being beliefs. Okay, so armed with our knowledge level view, we now move to the next level down in our hierarchy, that is the symbol level, where all this view has to be implemented. So knowledge is whatever can be ascribed to an agent, these are again Allen's words, such that its behavior can be computed according to the principle of rationality, so whatever can be ascribed to an agent, and it is characterized in an entirely functional way in terms of what it does, not structurally in terms of physical objects with particular properties and relations. So these statements reflect somehow the debate that was going on in the 80s about what counts as a knowledge representation and what doesn't count as a knowledge representation. So first order statement, first order logical statement are knowledge, Lisp expression not so much, database records not at all. These were the kind of discussions that were going on those days, and in order to sort out this kind of discussion, Allen said very clearly that knowledge is entirely functionally characterized. So it doesn't really matter whether what you have is a neural networks or is a logical theory. what is important is the knowledge that is exhibited at the knowledge level in the behavior of the machine. Okay. So this functional role is filled only indirectly and approximately at the system, at the next lower level, which is the symbol level. So basically the knowledge level doesn't impose any specific choice of what happens at the symbol level. Okay. As I said, a neural network is a perfectly valid candidate as long as it exhibits the behavior that we can call intelligent. But then the question always was, okay, if we want the system to have knowledge, why can't we just put every piece of knowledge that we need into a box and have it stored in the system and used for the purposes of whatever goal the system has? The early expert systems, Mycin and others, were suffering from this knowledge box, let's say, disease. Well, the problem is that there is too much knowledge to be represented. The knowledge is potentially infinite. Okay, so these are the words of Allen. It says, even if we look at the chessboard, okay, and the chess plays, which is one of the favorite AI scenarios, at least in those days, there is an immensely large number of questions that I may want to ask, and I may want my system to be able to answer. Can the queen take the pawn? Can it done next move? Can it if the bishop moves? And so on and so forth. So even though the chessboard is a very finite device, and the pieces on it are finite, and the way they can move is well determined and finite, the knowledge that I may want to extract from a chess player is potentially infinite. So this idea that knowledge is characterized functionally and is infinite couples very well with the generative ability of computational system. Okay, so a computational system typically works on an initially given data structure and evolves it in order to obtain the required knowledge, and knowledge is what comes out, okay, from the process. So of course, if we look at the internals of a program, we will discover that it can handle only a finite number of questions. Okay, but we have to look at the internals. The same program, if we deploy it on a larger infrastructure, may handle a larger size, and so on and so forth. So potentially, from the knowledge level point of view, the amount of knowledge that the generative ability of a computational system is able to handle is really infinite, as we expect. So when we move at the symbol level, given that the knowledge is too large to be put in a box, and that knowledge is never to be characterized structurally, what are the alternatives? Well, this is the second ingredient of my recipe. There are two alternatives, roughly speaking. The declarative approach, in which the desired behavior of the system is obtained by describing the domain of the problem, that is the what, in terms of logical statements. That's why it's called declarative, because our declarations of what the problem space is. And then the procedural approach, where the desired behavior at the symbol level is obtained by encoding it into a set of executable statements, okay, that implement the desired behavior. That's the how. And in the ICT community has been debating for decades about which of the two approaches is superior. And of course, each one has its own pros and cons. The declarative approach typically emphasizes readability, because you can read the knowledge statements, okay, while the procedural approach emphasizes efficiency. Okay. In the context of digital humanities, we think that declarative is preferable because it is more inclusive. It allows people who are not familiar with the executable statements of programming languages to be able, nevertheless, to interact with the system, to design the system, to deal with the system, as we shall see soon. Okay? So, knowledge level is our vision, and a declarative approach is our choice when we do DH systems. Which brings me to describe the symbol level, the structures that in our system we play with at the symbol level in order to implement the knowledge level are, simplifying a little bit the picture, just this. There is an ontology, there is a knowledge base. These are the two structures that hold the declarative knowledge that can be stated to make the system declarative. And then there is an engine, which is a piece of code that works on these two structures in order to obtain the generative ability of answering, for instance, to a potentially infinite number of questions and handling a potentially infinite set of scenarios. So, ontology and knowledge bases. Now I have to warn you that these two names have been used in many different ways. So in the early days of AI, the knowledge base encompassed both the ontology and the knowledge, what today we call ontology and knowledge base. In the semantic web languages, ontology encompasses both. It encompasses both what I call ontology and the knowledge base. I prefer to keep those things separated because I want to emphasize especially the role of ontology. So, what is an ontology? An ontology is a logical theory which gives the intended meaning of a formal vocabulary. So, what are the terms that are used to describe the domain that formalize a conceptualization, and how they are defined in terms of logical axioms. So, meaning here is logical. When we think of meaning as humans, we associate with meanings a lot of biological things, such as flavors, smells, and memories, and so on, that are not logical and so are excluded from ontology, at least for the time being. So the meaning that ontologies capture is logical. It's given by a set of axioms that describes the logical properties of the defined terms. Next slide, I will show you something of some of these axioms. In contrast, in a knowledge base, okay, so the meaning would be the vocabulary, and the knowledge base would be the encyclopedia, because the knowledge base, in the knowledge base, we put the facts that describe a particular state of affairs, of a particular epistemic state, of a particular set of beliefs that an agent is holding, and that are formed according to an ontology, to a certain vocabulary. So here you find the definition of what a medical doctor is, and in the knowledge base you find the medical doctors that exist in a certain place, in a certain time, and what they do, and so on. So what are the axioms, what are of the ontology that we used for Dante sources? Well, some of these axioms are put here. So for instance, I put in bold the words that represent classes, and in italics the words that represent a relation. So a work like Divina Commedia is an information object that results from a creative creation event which is carried out by a narrator. So this is a possible definition of work that says something, not all, but what it says it clearly in logical terms using relations with other terms in the same vocabulary. So a work can be composed of several parts. Each one is an information object. The composition property that relates a work and its parts is transitive, reflexive, and antisymmetric, and these are the kind of axioms that go into an ontology, for instance, for Dante sources for the digital humanities. So, quickly, ontologies use the language of science, which is logic, and or not, every, some, implies, and mathematics, at least, no more than, transitive, symmetric, and to provide rigorous, unambiguous definitions of the terms of the universe of discourse. They are an essential element in communication, as we know since we are 2 years old, because they help what to say, they help to say what can be said clearly. So, in case you're wondering what's the answer to the question in the title of the lecture, the answer is yes, of course, it can be said clearly with ontologies. Now, in the digital humanities, ontologies also are, in my opinion, a very valid tool. For instance, they help avoiding the information silo problem created by data models. So whenever you try to create a digital version of something, and instead of using an agreed, common, well-founded vocabulary, such as an ontology, you create your own data model or XML schema or whatever you have it, and put the data there where you're not really doing a good job to the community. You are creating an information silo. And it is precisely to break those silos and share that ontologies and the semantic web languages have been invented. But they are also nice because they are independent from any operational model at the symbol level. So they are the ideal place where the humanist and the IT technologist can meet and collaborate to realize digital humanity system. This is a particularly important aspect because I'm working with humanist scholars since at least 5 years, and understanding each other has always been a problem. And the first problem has not been agreeing on a certain term or another term, is to decide what language are we going to talk when interacting with each other, okay? So not Latin, not Java, not UML, but the language of logic, which is what all languages, if you like, have in common, the underlying structure that all relevant, significant language have. And so they are good candidates to play the role of lingua franca for the communication between the humanist scholar and the IT scholar. So this is the reason why in any interdisciplinary context, ontologies are even more important. There are several kinds of ontologies. You probably heard about top-level ontologies, which describe concepts like space, time, matter, object, these things that philosophers and theoretical physicists, theoretical scientists discuss. And then there are, at a lower level, so as specializations of these concepts defined here, domain ontologies and task ontology, which describe the vocabulary related to a particular domain like medicine, automobiles, or tasks by specializing the terms introduced in the top-level ontology. So in the top-level ontology, you have the concept of event, and then in the domain ontology, for instance, in the medicine ontology, you have the kind of events that are relevant in the in this particular domain. And then when you build application, you pick from domain ontologies of different kinds, perhaps, and from task ontology you select and you build specific application, specific ontologies that help you sharing and creating a system that is not an information silo. Okay. So in the digital humanities, my understanding is that they deal with the product of human culture, text, documents, objects, artifacts, images, sounds, and the relationship that they bear to each other and to humans and their deeds. So the formalization of these entities as in terms of formal system is ongoing since many years. The first guideline of the text encoding initiatives were out in 1994. Now we are early this year, version 3.3.0 has been released, an incredible amount of work for formalizing text. This is very relevant. For the other entities, documents, images, sounds, complex objects exist. Not all of them take the form of ontology, because this idea of using logic as a communication language and as a declarative tool to instruct system at the symbol level to tell them what we want them to do has probably yet not been completely spread. But in my opinion, we are going towards a blossoming of ontologies from what I can see in digital humanities coming from the bottom up way in a natural process. Okay. Of course, the process will never end because human communication and the human culture will always find new forms of expression, and so we will need to update and regulate and axiomatize these new forms of expressions. Fine. We are used to the idea that language is a living creature, is a living organism, so we're not scared by this. And of course, in addition to the representation of this, is always on the background the representation of meaning. And the representation of meaning finds in logic its natural expression and in an ontology in particular. So, in my opinion, the digital humanities are very well placed to embrace and to a certain extent have already embraced this way of representing and structuring system at the symbol level. In particular, we've done two projects so far. One is about Dante sources. So in the rest of the talk, I'm going to exemplify those two principles that I have been giving you so far by showing how we have implemented them in two particular systems. One is Dante sources, and one is the DL narrative tool. Dante sources is a finished project, it's also been well received, and we are very happy about it. The other DL narratives looks like our life endeavor, because it's much more general. The representation of formal narratives, it's a much more general problem. It's much more difficult, but I believe it's worth doing it. So we had an Italian national project per una enciclopedia dantesca digitale that aims at creating a big digital library endowed with the services supporting scholars in creating and evolving and consulting a digital encyclopedia of Dante Alighieri's work. Okay? So said in this way, it looks great. In fact, what happened is that Professor Tavoni gave me an Excel spreadsheet and said, these are the reference to primary sources in the Dante Convivio. Okay? Please make a system to consult them and build primary sources reference of other, the Monarchia, Rime, and so on. I said, good, thanks. first things, we throw away the Excel spreadsheet, we get the information out, and to the astonishment of Professor Taboni, we say, what is a reference to a primary source? He said, if you don't know this and you don't want to use Excel, then the project is already over. I mean, where are we going? We can create beautiful charts with Excel. We can display the information in so many nice ways. Why? He said, no, but we need an ontology. I know what a reference to a primary source is. I've done my lyceum more or less decently. But we have to tell the agent. Where's the agent? I mean, the system. The system is the agent. Yes, don't worry. I mean, just let us agree on what a work is, a reference to a primary source is, and then we'll take it from there and we'll... in spite of this initial astonishment, the collaboration with the Department of Philology, Literature, and Linguistics of the University of Pisa went very well. Professor Taboni was conquered by the idea of creating this ontology, and in fact, we got a lot of work, but this is a side issue. So the focus of Dante Sources was on giving scholars creating the encyclopedia statistics on how many citations to primary sources were there in which work of Dante and to what. The idea was that by studying the way Dante quoted primary sources, it would be possible to obtain an idea of the evolution of Dante's knowledge. Okay? This is, of course, outside the scope of the system. The system just displays the statistics, and it's the scholar who draws this kind of conclusion. And then what, in fact, was the impact of primary sources on Dante's thought. So, again, following our approach, we built an ontology with the definition of the terms that are relevant to this domain. Some of the axioms of this ontology have been already shown to you. We expressed this ontology as an How-to-DL ontology, set of axioms. And then we very patiently derived manually from commentaries that we were given the references from each work of Dante to primary sources, and we put them into a knowledge base that was then massaged by an engine that, upon answering queries like how many references to Etica and Nicomachea are there in the first book of Convivio, would be able to reply to this kind of answer. Okay, so this knowledge is expressed also as How-to-DL axioms, and it follows the linked data recommendation. So every resource which is not defined by someone else as a URI, there is a description for every source, and it links to certain databases, in particular to certain ontologies, and we would also hope to have links back to us. And we implemented everything on top of the virtuoso Sparkle query engine. So, as I said, in order to avoid not creating an information silo, we wanted our ontology, first of all, to be an ontology, a principled description of the terms of our vocabulary, not an idiosyncratic one. And also we wanted to be interoperable. So we have analyzed existing ontologies. We have analyzed quite a few. And finally, we decided to adopt those that I put here in bold. And this led us to understand and to know that, in fact, at that time, which was 5 years ago, there weren't many ontologies in the digital humanities, at least not of the kind we were interested in. So in fact, this comes from linguistics, this comes from social science, this comes from library science, these are very specific, this comes from a World Wide Web Consortium initiative. Today the situation is a little bit better. So this is what our knowledge base looks like, a fragment of knowledge base. So we have this piece of text in Dante's Convivio, as the philosopher says in the beginning of the first philosophy. This is a clear reference to primary source. Who is the philosopher? Okay, so we have modeled this as an instance of an expression fragment class, which we borrowed from the FRBR 00. We have used a certain test of the commentary that says, well, these are the words that open the Aristotle's metaphysics. So this work is the metaphysics, and it's about Aristotelianism. And the person who created this work is Aristotle. So here you find a fragment of our knowledge base that basically says, actually relates a fragment of Dante's work to a fragment of a commentary that says that this, the former fragment, refers to metaphysics. Again, this is the belief of the commentary. It's not really knowledge like, the law of gravity or other things. Okay. So the knowledge base of Dante sources now contains this information: primary sources, cited authors, cited thematic areas, the type of reference, which is one of three kinds, and these are the works of Dante that we went through. And this is the name of the person who authored the commentary that we relied on. All manually done. Of course, we can apply text processing technique, natural language processing technique, but we don't have too many expectations regarding, because we cannot afford to have incorrect information, inaccurate information in our knowledge base. So in any case, automatic tools can give us hints, but there is always behind a scholar that validates the hints given by the tool. The project has ended in 2017, and then we have expanded it by including a representation of the most significant events in Dante's life, especially those related to the creation of these works. And this was our first step towards the next project. It was done in cooperation with a historian which is specialized on Dante's biography. And it worked basically as a feasibility study of a more ambitious project, which is the DL narrative project. Okay, so the DL narrative project comes basically from my experience with Europeana and with the slightly depressing information discovery service that you find nowadays on digital libraries. Okay, so you go to Europeana, you ask the query Klimt, and what you get is a set of, I would say, graves, okay, objects that are related somehow to Klimt, but they are listed with no particular relations between each other, and also the relation to Klimt is a bit extravagant in many of the cases. So if you go to the library of my village and they have 3 books about differential equation, then the 3 make a meaningful answer to a question, and the librarian will explain to me which one of the 3 I need to use for what purpose. But if you go to a modern digital library, where every answer, every question has thousands, if not more, of objects as an answers, this is clearly not usable. So my motivation was, well, why don't we try to exploit better the wealth of information that digital libraries have in their catalogs, in their gazetteers, in their authority files, and so on. And we try to create an information structure around those objects that tells a little bit more, that works as a semantic glue between the objects, the people, the places that are involved. So this semantic glue is the narrative. And in fact, there is a more general motivation, because as we looked a little bit around us, we found that the notion of narrative is really pervasive. It shows up in many different contexts related to the communication of knowledge. Scientific papers, for instance, what are they? They are narratives of how an experiment has been conducted and of the data that have been used, the tools that have been used, and the series of experiments that has been done. The news, history, digital curation. Can you do preservation of an object without having any kind of information about the context where this object lives, where it comes from, and so on? It turns out that narratives are also relevant for preserving objects. So in any place where it is important to offer, a formal account of a sequence of related events, which collectively narrate something relevant for a specific domain or application. So this is quite a wide range of applicability. So what was the background we looked at? Well, given my history, I looked in artificial intelligence and in robotics, where events, the event calculus, the sequence calculus, there are several kinds of formalism that have been extensively studied, but this turned out to be very limited, okay, because the narratives you may have to deal with in the digital humanities are very different from the sequence of events that a robot goes through while trying to solve a certain problem. Okay, so you may have a narrative that spans 1,000 years, with events being very remote from one another. So there is no law of physics that you can use to relate these two events. Okay, so we widened our scope, and we looked at narratology, and then in particular computational narratology, where the notion of narrative has been studied with a broader, I would say, perspective, and we found there a good conceptualization we could rely on. So our approach to the problem of digital narratives, not surprisingly, I would say at this point, is to build a narrative or a series of narrative around an ontology that defines all the terms that are relevant in a narrative, around a knowledge base that contains a number of narratives relevant to a certain domain and which are interoperable with other narratives because the ontology is possibly shared, and with an engine to perform the basic operation of narratives. But then to develop the ontology, which is quite broader in scope than the ontology for Dante sources, we needed to rely on some conceptualization of what a narrative is. So we looked at narratology and computational narratives in general, and we found this definition that we liked very much, in which a narrative consists of three main elements, which is the fabula, that are the events that compose the story in chronological order, so the real happenings in the real world, that the narrations, which are one or more text, more generally media objects, why not a movie, why not an audio file and so on, that narrate the fabula. And then what we believe is the most important part of our representation is the referent function that connects narrations, pieces of text, to the events that the piece of text or the scene in a movie narrate. Okay, so this is the conceptualization that we chose, and basically we came up in our project with a conceptualization of the fabula. Okay, so what kind of relations do we expect to find in a fabula? We know there are events. We characterize them. The list is not probably not exhaustive as far as we can tell. For the moment, it contains all we need. So there is a mereological relation that relates events to other events that include them as parts. So, for instance, the event of the birth of Dante is part of the life of Dante. There is an occurrence relation which associates each event with a spatio-temporal region within which the event occurs, okay? Spatio-temporal, you cannot really detach them, okay? So we have in our implementation, because for practical reasons and so on, but as we know from, for instance, archaeology, but also from the relativity theory, we cannot really take them apart except in certain occasions. And then there is a causal dependency relation, which relates events that in normal discourse we describe as having a cause-effect relation, such as the eruption of the Vesuvio caused the destruction of Pompeii. Okay? So to have the maximum interoperability, we expressed our ontology using a top ontology, which is actually standard and a very well-known tool in the digital humanities field. And we have used one of particular extension of the SciDoc CRM, which is called the CRM-INF, to account for the fact that representation of the fabula is somewhere in reality lost forever. Representations of the fabula are in our knowledge bases, and the representation of the fabula reflects the beliefs of a narrator. So one narrator may narrate a certain battle of a certain war in a certain way. A different narrator may come up with a completely different narration, an inconsistent one, actually. So in order to account for the fact that this is belief and not knowledge, we have introduced a new level of representation, which is we call provenance, that enriches the reference functions, that connects narrations to fabula, but in addition, it describes the provenance, how the narrator came to believe what the narration tells. Okay, so much for the theory. This is a fragment of the fabula, not of the fabula, of our representation of the fabula, so of the knowledge base of a fabula. It concerns Dante Alighieri, which is a person, and two events, the birth and the baptism of Dante. The first one brought Dante into existence. The second one had Dante as participant. These numbers and names are notation for the CDOC CRM. And there is a temporal ordering relation between these two events, that the baptism occurred after the birth, which is not grammatically controversial. Now, the narration of the fabula, which is the biography of Dante that we worked with, okay, looks a bit complicated, but it is in fact an information object, okay, which has been the result of a creation event carried out by a narrator, which is a person. Okay, this is part of the ontology, by the way, these relations. And the information object, which is Dante biography, is composed of a number of sections, or chapters, if you like, that are information objects. Each one is composed of a number of sections. They're all information objects. Finally, we come to a fragment, to the fragment that says that certainly Dante was born in Florence. Narration. Now, reference. How do we relate the fact that certainly Dante was born in Florence with the event of the birth of Dante? Okay. Well, we use propositions. So we say that this fragment is about a certain proposition that has as a subject the birth of Dante, as a predicate where it took place, and where object is Florence. And the same information is reflected in the fabula by this link. So we have two levels of representation of the same information. So basically this is the reference function, because it connects a piece of text with the event that the piece of text narrates. But how do we reflect the fact that this connection is only in the mind of one particular narrator? Another narrator may believe that the same event took place in a different place, or at a different time, or perhaps never took place because Dante never existed. You never know. So, and this is how the provenance information is reflected, is that this proposition P1, okay, is part of a set that has been believed as the result of an inference making, starting from a set of premises, which are a set of propositions, okay, and some of this proposition is the result of an observation. So someone read somewhere, they trusted that Dante was born in Florence, or read something to that effect, formed a set of propositions which the person believed, used to make an inference, which in the end brought the person to believe that actually Dante was born in Florence, and this thing was written down in the biography as a piece of text, Dante is born in Florence. So this admittedly complicated graph accounts for the fact that we are dealing with beliefs and not with knowledge. So technically speaking, the system knows that someone believes a certain thing. This is the true logical expression. Okay, we have built a tool for building and visualizing narratives, and the tool allows to build narrative, in fact, mostly fabulous for the time being, by assembling events and objects which are, for the moment, imported from Wikidata, and it's based on a simple ontology which extends the SciDoc CRM. And that's the website of where the tool can be found, and there is some work in progress. We want to express the full ontology in OWL2DL because we have very specific axioms that relate to narratives. One of these axioms says that if an event is a sub-event of another event, then the temporal occurrence of the sub-event is included in the temporal occurrence of the super-event. So these are the kind of axioms that we want to capture, and the same for space. There is a temporal reasoning going on, because once we capture explicit knowledge or explicit beliefs about event and their occurrence in time, we may want to be able to deduce other temporal information, for instance, using the axiom about event inclusion that I told you. And for this, we need to be able to reason on those time intervals. And for this, we are using Allen's algebra. So if we want to display a narrative on a timeline, we need to know as precisely as we can the temporal occurrence of each event. And so we need to be able to deduce this information if we have enough knowledge to deduce it. So we need to reason in order to create, for instance, timeline. We are working on extracting knowledge from text. We have in our lab a group which nowadays is composed of people younger than me, so they are all in love with deep learning and neural networks and so on. So they promised me that in 10 minutes I will be out of business and that their neural network will do everything. I said, okay, let's work together. I am ready to be convinced. And then, of course, we are also working on a better visualization, for instance, in relation to certain specific domains. Okay. So, but this is not going to be finished anytime soon. Of course, I mean, I don't need to tell you. We will have approximations, and we will have new versions of the system, and perhaps some low-hanging fruits can be grasped now, but not too many. Okay, so especially the full ontology is giving us a lot of pain. Why? Well, because, for instance, we have to deal with different and possibly contradictory versions of the same story. And by different, or even the same narrator, they change their mind, of course. So we want all these narrations and fabulae to be in the same knowledge base because we want to be able, for instance, to compare them. But if we put all of them in the same knowledge base, then we get easy a contradiction in the system. And once the system has a contradiction, it breaks. Nothing works anymore. You cannot rely on Sparkle for doing queries and so on. So we have to find a way of having our cake and eating it too, as they used to say. Event identification. So if the event of the birth of Dante is irretrievably lost from the past, okay, how do I know it occurred? How do I know where it occurred? And if someone is saying the birth of Dante was this day and this place, and someone else say the birth of Dante was this day, are they the same event? But theoretical physics says no. They are different events. I mean, if they occur in different time and times in different places, then they cannot be the same event. But of course, they are the same event. So we are talking of the birth of Dante. So how do we identify events? How do we nail them down so that even in presence of imperfect, incomplete knowledge, we are sure we are talking about the same event? I don't have an answer for that. What I can tell you is that the objects that we threw out of the door are re-entering from the window because Dante Alighieri, okay, if he existed, then there must be an event of his birth. So we can nail down the event of the birth of Dante by linking it to Dante. Okay, and then we can express that someone believes this event took place in this time, and some other believes something else, but we are sure it's the same event. Can we generalize this? Is there always an object that we can nail down, we can use for nailing down an event? Of course not. So, being close to the end of the talk, I'm also close to. So this dramatic narration of our research on narratives should not make you believe that it's over. No, we are in business. We are alive. We like what we do. We think that the knowledge level view can help the digital humanities to have a more effective view of what computers can do for the digital humanities. Look at them as knowledge processor and give them axioms and propositions and use them to reason about your domain. How to do this? Well, in the 80s it was a bit difficult. Nowadays it's a lot easier because, well, a lot more possible. Ontologies we have understood the values of ontologies. We have several of them around. We have tools that manage them, so we are in a better position with respect to defining the formal vocabulary of our domain. So we have ontology, and we have also, we can use them, ontology, for the communication between interdisciplinary fields. So according to my experience, if I have to go now and talk to a humanist scholar, no matter what's the field, okay, I will try to do this at this level. Okay? It may be difficult at the beginning, but then it always pays off because the humanist will feel relieved that I'm not talking about Java, XML, spreadsheet, triple stores, and HTTP and whatnot. And although sometimes it is not easy to pin down concept in terms of axioms, but if it can be said at all, it can be said clearly. So let's have a try, and let's develop our own ontology, and we will evolve it if it proves not to be working. The third element of the recipe, knowledge level and ontology, is the web. The web, in my opinion, gives a big help. First of all, it has created the languages for expressing ontologies and knowledge bases. You know these standards very well. It has given guidelines for using these languages, linked data, and it has given a big infrastructure for sharing whatever we build using these languages and these guidelines, which is the web itself. So the same way you retrieve your favorite web page for the news, you can retrieve your favorite ontology and your favorite knowledge base describing Dante's work, for instance, and whatnot. So this is the way I look at things, and this is the way I think DH can have something to do, will be busy for the next few years or so, and will be able to create intelligent systems. And this is all I have to say.
Thank you very much, Carlo. Thank you very much for giving us plenty to think about, and I'm very pleased to hear that you're going to be around and in business for some time yet, and we're not closing down. We have a few minutes for questions. We have about 10 minutes. If you can wait for the microphone so that we can all hear you and pick you up on the sound. Thank you.
Hello, thank you very, very much. That was an eye-opener for myself. I'm not an expert in ontology and I'm not related to this, but I am. My research is in relation to modeling socio-technical problems for future robotic cities under the systems engineering group in Willard Space Science Laboratory. And my focus is related to social interaction with distributed robotics. And it's interesting how you have stated that we are dealing with the beliefs in some times, not the actual knowledge. So some problems, regardless of their NP-hard modeling, we can still find an optimal solution from a computing perspective. But if they're wicked problems, and from a wicked perspective, then there is no real optimal solution. And vast research suggests that co-creation of knowledge between human and machine, or human and experts, in other words, would be the way forward. So it's not really a question. I'm asking to pick your brains on this, which is, don't you think that when you represented the knowledge base and the ontology and the agent, as in the model, isn't that representing the agent? And if we're going to deal with the super system, then we should also model the epistemology, not just the ontology. And wouldn't it be a way of taking taxonomy from a tree testing perspective in order to find the different perspective for the different narratives? Isn't that similar to the the fabulous that you have mentioned earlier? Can it be a different way of representing it? I'm sorry if I have...
No, I didn't get the last part of your question. So the first part was about representing the epistemology of the system in the system, yes. And the second part was about...
The second part was related to the fabula,
yes,
and how you have modeled it.
Yes.
Isn't it possible to do a similar or a different way to that, whereby we could do the taxonomy of the different phrases that exist, so that the system as an AI system could understand, using tree testing, the different narratives?
Yes. Okay. So
thank you.
Thank you. Epistemology. It's correct. So an agent has a set of beliefs and has an epistemology, which means that the way beliefs are formed, the way the agent comes to believe or to know a certain thing, or to disbelieve or to reject a certain knowledge. Okay. There has to be this in the system. The problem is that doing this declaratively, so writing down the axiom according to which axioms are formed, so we are talking about a meta level here, we don't have, to the best of my knowledge, we don't have a lot to build on. Okay? A lot to build on, in the sense that the philosophical studies, okay, on a possible artificial epistemology, okay, in my opinion, as far as I can tell, are not at the maturity on giving us the possibility of going out and implementing tomorrow, even in a very simplified form as the one that it would take for a simple agent like, for instance, Dante's uses. So in my opinion, we are talking about notions that are very controversial, and the last time I looked into the semantics of natural language, which we try to assign a precise meaning to propositional attitudes and so on, we are a little bit, I would say, in a premature state. Okay, so this is, but it is very important what you say, because it allows me to say something that I forgot to say. The problems that the philosophers in ontologies, the applied philosophers in ontology are studying are relevant to us. Not all are relevant to us. Not all of them, okay? Not all of them. But when we have philosophers that have modeled in a final way, for instance, mereology, okay? That's a solved problem, and then we can build on top of it. So what they are, not only ontologies are relevant, but the research in ontology is relevant, because it is from the answers that the research will come up with, we can find the fuel for our system. For instance, what you say, okay, coming to, if I understood correctly, a declarative representation of the epistemology of a system. Okay, how axioms and beliefs are formed, how knowledge is accepted or rejected. Okay, so the second part, to use the fabula, okay, to relate a certain process to a taxonomy of phases, you say, that's perfectly, it makes perfect sense to me. I haven't studied the specific problem that you discussed, but it is one of the possible usages. And in fact, this, I've seen many systems that, for instance, in the news domain, they jump from the text to the conclusion. For instance, from the text to the summarization of the text, or from the text to a video that shows some part of the text. Well, we found, and we have some confirmation of this, that this intermediate level of representation, the formal level, with the knowledge base and so on, gives us the opportunity of discovering more properties, for instance, reordering the event if in a narration the author chose to tell the end before the beginning and so on. So this intermediate level may play a role in obtaining more performant system. So, and in particular also the case that you mentioned seems to be a case in point.
Thank you very much. We need to be winding up. Sarah is downstairs in the cloisters where we're having the reception, protecting everything and waiting for us. But if anybody has a very, very short and quick question, otherwise I'm sure Carlo will be happy to speak to you downstairs. In that case, speaking as someone with a background in classics, I was very pleased to see you using Aristotle's metaphysics in the combination with Dante in there. Any presentation that has Aristotle in it is tops in my book. But the reception is in the cloisters, which is directly downstairs from here. We have signage pointing you to the directions, but if you're not familiar with UCL, just follow everybody else. The students know where it is, just follow them. But we should just thank Carlo one more time before heading off.
Thank you.